we start working on the SQL queries. So let's learn some more basic concepts. All right. So this time about SQL tables. Yeah. C.1, create a table. Yeah. The command we use, create table statement. Yeah. So we saw that before. Yeah. But some details. So this round, we will add some more details. Yeah. So this command specify a relation by giving it a name. So here the relation, last time I mentioned, in that academic project, we use the formal name. Yeah, but in business world, we use the table name. Yeah. So here, some of you may feel calling relation a little strange. Yeah. Yeah, because these terminologies are people, different authors, so they may use different names talking about the same concept. Yeah. Attributes, the fields, the columns of a table, the format. So when you declare attributes, so you use the name, comma, data type, comma, constraints. Yeah. So in one row, you use this way to describe one column or one field of the table. Yeah. But the constraints, later we will see, the constraints this way, usually, when it is a simple way, simple constraints, we use this way. Okay? So this way, mainly used for simple constraints. Yeah. Not for complex constraints. Complex constraint, because our description is relatively long. The simple constraints usually, very short. Very short. So we use this way to describe. But for long, complex constraints, then we need to use one complete SQL statement to define it. Yeah, later you will see. We add a constraint. Yeah. So after we define the table, then we can add more constraints. Yeah. So we will see those cases. If the constraints are very simple, very short, let's just use this simple way to include the constraints. Yeah. Yeah. So the constraints here, there are several simple constraints. The first, the key constraints. Yeah. The key constraints, we know the meaning of key, the values must be unique. Yeah. The values of this field, values must be unique. Yeah. Yeah. We do not allow duplicate values. Yeah. The reason I mentioned before. Yeah. So some of you may want to ask why we want to talk about the special cases for which the values must be unique. Yeah. The reason in our module 5 we will know, because with this property, uniqueness property, we take advantage. We use this property. We can make search operation fast. Yeah, that's the main reason. Yeah, for the key field, then we apply the binary search. Binary search. Yeah, you are familiar with the binary search on this field. Yeah, then we can do very fast. Yeah, but for duplicate values, for the field with duplicate values, then the search algorithm, although we can still do the binary search, but because in order to consider the special property of the duplicate values, we need to do a lot of work. So that's the reason, the search op will be slower. Slower than the search operation when applied on the key fields. So these two types of data we want to separate. The algorithm, the underlying search algorithm for these two type of data, quite different. Okay, for key and a non-key field, the algorithm, search algorithm is quite different. So that's the reason. In order to tell the DBMS, so if you know the values of one particular column must be unique, you should declare uniqueness constraint. Because when you do that, then you have chance to make the search operation faster. All right. So that's the first simple constraint, key constraint. Second, entity constraint, integrity, entity integrity. So here we talk about the primary key. I talked about primary key before. So the main reason we use primary key in a table, we want to identify different roles. Because when you modify your data, you want to identify the roles. So you want to pick the right role to do the modification. How do we pick the right role, correct one? The most convenient way using primary key. Most convenient way. But sometimes a table may not have primary key. That happens. It is allowed for a table. Sometimes there is no primary key, but you want to modify the data. Then you need to find different ways to modify the data. Okay? I mentioned before in our second project, we will modify the data for 5 different tables. The first 3 tables, they have primary keys, but the last 2 tables, no primary keys. So, but we need to identify the roles. Then we need to do some work. Now, in our programs, we need to, really do some special treatment. For primary key, that's easy. We just, retrieve the primary key, then we can modify the data immediately. For non-primary key case, we need to do more work. All right. So the primary key value cannot be null. But most of the time, you do not need to declare it. Because by default, the primary key, so this property, automatic, not null. This property for the primary key, it's automatic. So here, even you do not declare it. The primary key field, the field you use for the primary key, but you need to declare primary key. Okay, the primary key, this property, this declaration, you have to do something to do it. Later, in our C.3, you will see we will use 3 different ways to declare primary key. All right. So if you declare primary key, then automatically it cannot be null. It cannot take a null value. All right. Another one called the referential integrity. That's about foreign key. So this case a little more complicated. Yeah. So this concept, first the concept, foreign key concept. Yeah. So because we want to talk about the relationship between two tables. Yeah. These two tables, the first table, so we call a referencing table. Referencing table. The second one, referenced table. Okay, referenced table. So the first table refers to the second table because the primary key of the second table is used as one of the fields in the first table. Yeah. In the second table, yeah, so we need to use its primary key. Okay. The primary key of the second table is referred in the first table as a field. Okay, as a field. Yeah. All right, yeah. But you need to declare that relationship clearly, yeah, foreign key relationship clearly, yeah. But here, I do not want to explain this concept. It's too early. Yeah. So this concept we need to delay. Later, we will use a lot of time to study this foreign key concept. Yeah. Yeah. All right. So here you just know it. Yeah. Then, alternate way to add constraints. So, alternate way. Yeah. So this way, remember, simple constraint. So this way is for, relatively more complex way. Yeah. So this way, after the table is created, so you create a table first. When you create a table, some of the constraints are relatively complicated because it's not easy to add in your table definition. For that case, you can delay. Yeah. So when you define tables, you do not need to include those relatively complicated constraints. Yeah. So then after the table is created, then you use this special command. It's called alter table command. Then you can add constraints. Yeah. So you define constraints, you can write a lot of conditions. Yeah. So in that place, you can define some very complicated constraints. Yeah. So that way. Later, I will show you examples. Yeah. So for this class, I include a database, company database. I uploaded, so you can download. Yeah. In the part C of module 3, I include the database script called company.sql. Yeah, lowercase. C is the lowercase. Yeah. Because this file name, when you create a database, you use this file name as the database name. Yeah. Yeah. In this way, same database name. When you create it. Okay? Yeah. Yeah, but actually in the script, if you use a text editor, open the script, so actually we include that part. Yeah. You can just run the script. Yeah. In the script, we have lines. Yeah. Create the database and use this database. Yeah. Yeah. You can see that, those two lines. Yeah. Just let you know, as you will you will create this company database. Yeah. Then when we do our homework, all of our homework questions, yeah. So most of our homework questions, we will use this database. Yeah. 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 All right. Now let me show you one table in this database, employee table. Yeah. So this database contains 6 tables. There are 6 tables in this company database. Yeah. Among those 6 tables, 5 of them are entity tables. Yeah. Remember last time we talked about the entity table concept. Yeah. So the entity table, each one describe a business object. Yeah. Employee is a business object, right? So we have an employee entity table. And the department is a business object. So we have a department table. Then dependent table. So employees have their dependent information. So we have a dependent table. And the location table, department location, so there is a location table. Yeah, and so on. Okay. Our project. Yeah, there is another table called project. Project, also business object. And there is one table, that's the relationship table. Yeah. Only one relation table, the table called works on. So from the name, you can see that it's about relationship. Works on. Employees, each employee works on some of the projects. Yeah. So employee and the project mapping information. So we use a table called the works on table. That's a relationship table. Yeah. Here I will show you the employee table, the definition. Yeah. So this is the, table definition. Yeah. But in this definition, so you can see actually there is some information we didn't include in this table. Yeah, that is the primary key. You cannot find the primary key, right? So which one tells you it's a primary key? Yeah. Because we have another statement. Actually, we will use the social security number, SSN, as the primary key. Yeah. Yeah. And in the script I gave you, after the table is defined, it adds this alter table statement to add primary key. Add primary key constraint for table employee, and the field name is SSN. Yeah. After this command, SQL command, then that primary key is declared. Here you can see you don't need to specify not null. Yeah. So if it's but this SS already you include the not null. Okay. Yeah. Already include. Yeah. Yeah. But later you will see. So there is a simpler way. We just add primary key constraint here. Primary key constraint or primary key, keywords here. Yeah. So we can declare a primary key directly inside our table definition. Yeah. Yeah. I mentioned later you will see 3 ways. Yeah. 3 ways to declare primary key. Yeah. In C.3. Yeah. All right. The reason so here, why we do this? Yeah. Some of you may ask, why you do it separately, right? Yeah. So the reason is this. Yeah. Actually, the original. Yes. So here, the script. So here I talk about the script file company.sql. Yeah. Because the textbook contains this script. Yeah. So I downloaded from the textbook website. Now, the original file does not do in this way. Okay, the original file use this way. Okay, this way. Yeah. So then I populate the database. Yeah. So into my SQL PHP MyAdmin, that web application. After I enter the database, yeah, and later, yeah, because the original script many years ago, so I put in my old computer, so it's not easy to find it. So how do I give you the script? I export from my database. So I export this database from my PHP admin. Yeah, export it. But when I export it, yeah, the script is automatically generated when I export. So this syntax is used when I do the export. Yeah, because the export tool, they use this way, this type of syntax. Yeah. All the primary keys are declared using the alter table statement. Yeah. Yeah. All right, so that's the reason. Yeah. And the second table example, department. Yeah. Department table, you can see the alter table part, two constraints. The first one is primary key constraint, D number, department number. Yeah, primary key. Second, uniqueness, unique constraint. Yeah, uniqueness, this constraint, add a key. Yeah. Department name. Yeah, D name, department name must be unique. Okay, yeah, must be unique. Yeah, yeah, two constraints. So you use this one alter table statement. So you add two constraints. Yeah. Although these two constraints you can use the, for example, you use the unique here. Later you will see. Yeah. So we just added unique keyword or this primary key. So you use the primary key here. Yeah. Yeah. So you can declare these two constraints together in the table definition. Yeah. But because I export all tables from this database, yeah, so that export tool uses this syntax. Yeah. Yeah. So, but because you may ask me why you use this way, not that way, right? There are several ways. Yeah. Actually, for the uniqueness way, also three ways. Yeah. In C.3, we will see three different ways to declare. Yeah. 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 Base relation and virtual relations. Yeah. Base table. Just the name, we call it the base name, base table. So that's the physical tables, normal tables, physical tables. So virtual relation, the views, the concept we learned, the views, here. Yeah, base relation, base tables. Yeah. we just use the create table statement. We create the normal tables, physical tables. All right, the relation and its tuples are actually created, stored as a file. Yeah, remember last time I mentioned in the database concept, when you see this file, word or name file, it corresponds to one table. Yeah, because the underlying the storage format for each table, there is a physical file. Okay, yeah, for each table. Yeah, so sometimes some authors, database article authors, so they may use this way to call a table. Yeah, file. Virtual relations. Yeah, so in SQL we use view concept. View means a virtual table. Yeah. The virtual relations are created through create view. You just replace the key table keyword by view keyword. Okay, the remaining syntax is the same. When you create a view virtual table, so you have fields, columns. So how to define fields in a virtual table in a view, same way as we did in a table. No difference. The only difference, virtual or physical, is the name. The type of construct, view construct, table construct. All right, it may or may not correspond to an actual physical file. May not is the default. Okay, may not is the default case. That means if you create a view by default, no physical file is used. No physical file by default. Okay, because we want to save space. No physical file by default. But if you want to make it a physical file, you need to tell DBMS to do it. So you need to save the virtual table as a physical file to do it. So then you make it physical. All right. So here I don't want to repeat. Because we in the first time we talk about this concept, virtual table concept, we spent a lot of time. So here I don't want to repeat. Because why we use a physical table, right? I spent a lot of time. Many reasons. So here so we can. And also we spend a lot of time talking about derived data. Okay? How to apply derived data to improve response time. All right. Next, order property. So this order property, I mentioned that before. Remember in the part A. Part A of module 3, the last slide, I talk about this property. And here, let me just talk about this property again. All right. So we need to look at different cases, ordered or not. Sometimes the order of objects. When we talk about order, you need to look at the order of some objects, order of elements or objects. Yeah. Sometimes order matters, but sometimes order does not matter. Yeah. All right. So in the attribute case, the order matters. In the tuple case, the order does not matter. Yeah. So here, let me explain. Does not matter. Yeah. So this probably we mentioned before. Yeah. Here we just repeat it. Yeah. Attributes, columns. The attribute in a base table are considered to be ordered in the sequence. Yeah. Because when you declare attributes, you need to specify in a sequence, right? So the order in that sequence, that's the natural order. Yeah. Natural order. Yeah. They are specified in the create table statement. Yeah. So by default, you take that order. Yeah. But when you retrieve information, you can change the order. Okay? Yeah. So later we talk about when we retrieve data, we need to specify some order of the fields in a sequence. Yeah. Yeah. But in that case, order matters. Yeah. When we use in attributes or fields, columns. Yeah. Tuples, this case, this case, it's very easy to get confused. Yeah, this case we need to, understand in the right way. Yeah, why the order does not matter. Yeah. In part A, I explained, but because that's the last slide near the end of the class. Yeah, probably many students didn't pay attention. Yeah. So let me just explain that property again. The tuples are not considered to be ordered within a relation. Yeah. So this sentence we need to understand in the right way. Yeah. The tuples. Yeah. First, the tuple. Yeah. Let me review. What's the tuples? Yeah. It's a math concept. Yeah. So we list a sequence of elements. Now, here, let's use the elements, because not necessarily numbers. A sequence of elements, A1, A2, group them, A3, we group them, ... AN. Yeah. Group in this way. Yeah. So that's the format of a tuple or tuple. Okay. Yeah. Yeah. All right. And in the tuple definition, the order matters. That means if you use all right, so inside here, yeah. So when we talk about orders, yeah. Yeah. Inside the sequence, that's one meaning. Inside the sequence. Okay? Yeah. So that's the one meaning. Inside the sequence, the order matters. Okay? The order matters. What's the meaning? So if we, for example, if I use I list A1, A3, A2, AN, that means it's a different tuple. Okay? Actually, inside the sequence, that corresponds to the attribute case, right? Order matters as attributes. Because inside the sequence, actually you're talking about those attributes. Yeah. Those attributes. So for attributes, the order matters. Okay? So this is different tuple. So this tuple, you just swap A to A3, so you get a different tuple. It's a different tuple. Okay? Yeah. But what's the meaning here? The tuples are not considered to be ordered within a relation. Then this situation is different. Okay? This situation we consider relation. It's better we use a table. Okay? Yeah, because the relation, too formal. So we like to use a, more popular name, table. Yeah. So in a table, usually we mean the structure of the data is a 2D, right? Table, you have rows and columns, 2D data. Okay, yeah. You have rows, one dimension, rows. All right. The second dimension, you have columns. So that's the data of a table. All right. Then, so for each row, so you have row 1, you have row 2, row 3, and so on. So you have multiple rows. Row M. Yeah, let's say row M. Yeah. All right. Then the meaning is not considered to be ordered. What's the meaning? So when you change the order on the rows, for example, so when you get a table, but we just arrange the rows differently. For example, we arrange R3 here, R1 here, and R2 here, yeah, and so on. Okay, the order of the rows different, yeah, but for each row the same. Inside each row we do not change the data, yeah, but we change the order of the rows listed in the table. Yeah. If you make that change, so we treat these two the same table. They are the same table. We do not change. We do not get a different table. So they are the same table. That's the meaning. Okay? So that's the meaning. Tuples are not considered to be ordered within a table. Yeah. Not this meaning. Okay? Not inside each tuple. No. The order of elements inside each tuple. Not that. Yeah. So you need to see the difference of these two cases. Yeah. All right. Yeah. Because later, when you answer some concept questions, you need to base on this understanding. Yeah. All right. So understanding, element inside a tuple are ordered. Yeah. Because inside table that corresponds to the attribute case. Yeah. So we are working on the attributes. Yeah. All right. When we treat tuples elements. All right. Yeah. So here R1 is an element. Okay. R1 is an element. R2 is an element. Okay. R1, this whole group of elements. The whole group of elements together, we call it one element. That is one element. Okay? Yeah. So when we treat tuples as elements, they are unordered. Yeah. Right? Yeah. That difference. Okay. So we view a relation as a set of tuples. Yes. A set of tuples. So here, be careful. So here, yeah, another concept. Another important concept. Here we use the set. Yeah, when you see the set, you should pay attention. What's the meaning of a set? Yeah, we need to pay attention. Okay? Yeah. So actually here, when I use this this name here. Yeah. I need to specify its meaning. Yeah. So there is important subtle understanding here. Yeah. Regarding the set. Yeah. Because the set, if you use general English to understand, you do not require much, just a set. You put several objects together, you call it a set of objects. But set has special meaning in math. Yeah. Set, this concept comes from math. Yeah. So first we need to understand its meaning from math. Okay, original meaning in math. Yeah. And the second, in database, we need to modify the meaning. Yeah, because in database, if we use the original concept from math, it cannot reflect the business world situation. Yeah. So we need to modify. In order to use it in the business world, we want to change some of the properties of the set concept. Yeah. So we need to talk about that. So this slide I want to explain regarding tables, yeah, because we want to understand tables better. Sometimes, yeah, so we use a set of tuples, yeah, but there is another concept called a multiset. Multiset is our modification in database. Yeah, set we use the math concept. So we still keep the math concept. Yeah, math concept. Yeah. But in our database, we need to do modification. Modify the math concept. Modify the math concept meaning, for business. Yeah. Because if we do not do the modification, it's not convenient in business. Yeah. So let me explain these two concepts. Yeah. Between SQL and the formal relational. So formal relational model, we know, the academic project, right? Academic project before. So SQL was created as an academic project before it was adopted in the business world. Yeah. All right. So then later it was adopted in the business world. Some concepts or some special properties should be modified. Yeah. In order to support business better. Yeah. So this is set to multi-set modification. This is the important one. Yeah. SQL emphasizes on real-world applications. Yeah. Because when those researchers, when they created the academic project, yeah, so they couldn't cover all the business situations. Yeah. Yeah. So they created based on logic. Yeah, based on logic. So they created this project. Yeah. But when business people use SQL, yeah, so some concepts. So if they still use the original definition, so they feel not convenient. This is one. Yeah. because in the formal table, yeah, so formal table, yeah. So here, this formal table, the meaning, so meaning is a set of tuple. A set of tuples, yeah, in the academic project. Yeah. But in the business world, if you want to make each table a set of tuples, then it's not convenient. Yeah. So what do you mean? So here, in order to understand this better, first we need to understand the set better. So what is a set? Yeah. So let me recall the meaning of set. So the set we use its math meaning. Okay. Math meaning set. What is a set in math? All right. Yeah. A group of elements, right? Yeah. Yeah. So when we talk about set concept, yeah, actually in math, there is no definition for a set. Yeah. 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 Because why there is no definition for a set? Yeah, because it's the lowest level concept. Yeah. How do you define a concept? When you define a concept, you may need to use other basic concepts to define a concept, right? Yeah. But if a concept is already the most basic one, yeah, you cannot define. Okay, the lowest level concept, it's at the lowest level, so you cannot define it. So set is one of them. Set concept in math, there is no definition. You cannot define it because it's at the lowest level. You can use set to define other higher level concepts, but the set itself is at the bottom level, lowest level. You cannot define. Okay, although you can describe it, but you cannot define it. Okay, yeah. So we just here we describe set concept. Yeah. A set is a group of elements. With the following properties. With the properties. Yeah. Two properties. The first property, uniqueness. Yeah, so you know the meaning. So the elements in a set cannot be duplicated. Okay, all the elements must be unique. So uniqueness property. Yeah, so that's the first property. Yeah. Second property, unordered. Yeah. So if you change the order of the elements in a set, you do not get a new set. You have the same set. Okay. Yeah. So these two properties, basic properties of a set. Yeah. So if you use math concept meaning of a set, you have to include these two properties. Yeah. All right. So then, what's the meaning of a set of tuples? If you use the original set, when you talk about, use this definition, a set of tuples. Okay, unordered, that's fine. Yeah, we still keep that unordered property, right? Yeah. So tuples in that set because we refer to a table. Yeah. That set corresponds to a table. So tuples in a table, they are unordered. Yeah. So we keep this property. But uniqueness property, this uniqueness property, there is a question mark. Do we want to still keep the uniqueness property? Yeah. If we want to keep the uniqueness property, then we require that two rows in a table cannot have the same value. That's the uniqueness property, right? The values cannot be, the tuple values cannot be unique. So that means, yeah, so here let me just use a three tuple. Yeah, in a tuple, three elements, okay? Yeah. A1, A2, A3, so you have one tuple like this, or one row like that. Another row with exact the same tuple value, A1, A2, A3. Yeah. So you have a duplicated rows. Duplicate rows in a table. The question is, in business, do you allow a table to have duplicate rows? That's the question. Okay? Yeah. The question. Do you allow a table to have duplicate rows? Okay? Yeah. Yeah. Because if you keep the meaning from the formal relational model, formal table must be a set of tuples. Yeah. If you keep that, then you do not allow duplicate rows in a table. Okay? So all the rows must be unique in a table. That's for the formal relational model. The researchers in that academic project, they require that. All the rows must be distinct in a table. Yeah. But then the business people then when they deal with the real world data, they feel it's necessary to allow duplicate rows in the real world situation. Yeah. It happens a lot. Later you will see in many business situations, we want to maintain the data in a table with duplicate rows. We need it. We don't want to remove the redundancy. Yeah, that's not actually not redundancy. We don't want to remove the duplicate rows. Okay, we want to keep it. So for that reason, the business people, they modify the concept, set concept. So then they create a new concept. This multi-set concept was created to allow duplicate rows in a table. So they call it multi-set. Yeah. This concept is not available in math. So multi-set, this concept is not available in math. Okay? Math, you only have set concept. You don't have multi-set concept. But in computer science, especially in the database context, so we need to add this multi-set concept. Yeah. To change from set to multi-set, we just remove this uniqueness property. Okay, we keep the unordered property, but we remove the uniqueness property. Then you get a multi-set. Okay, you get a multi-set. Yeah. So that's the reason behind these two different concepts. Yeah. Why people want to use multi-set concept. Emphasize on rigorous, right? So views tables relation. SQL allows a table to have two or more tuples that are identical in all their attribute values. Yeah. So as a conclusion, or as a modification of the SQL in business world, then a table is a multi-set. It's not a set. Okay? Yeah. A table is a multi-set. It's not it can be a set in the special case. Special cases, it can be a set. But the general case, it's a multi-set. Okay? Yeah. Yeah. If we say a table is a set, we mean there are no duplicate rows. Okay? If we use the set word to describe a table, then automatically we mean there is no duplicate row. Okay? The hidden meaning, no duplicate row. Yeah. But if we use the multi-set, we allow duplicate rows. Yeah. All right. In the formal relational model, a relation is required to be a set. No tuple is allowed to be repeated in a relation. Yeah. So you need, after this slide, then later, we will use these two concepts, set versus multi-set, when we talk about table of rows. Yeah. All right. C.3, basic constraints. Yeah. Yeah. So here we only have 10 minutes. Yeah. So let's do one slide. Yeah. Actually, this part we have 3 slides. We can do 1 or 2. Okay. 1 or 2. Yeah. All right. Use the primary key clause. Yeah. So here I talk about 3 different ways to declare primary keys, right? Yeah. This slide we will learn those 3 ways. Yeah. Use the primary key clause to specify one or more attributes. Here there are 2 cases. One case is one attribute is used as the primary key, but the second case, sometimes we use more than one attributes for one primary key. Yeah, these 2 cases that make up the primary key of a relation. How to? Yeah. So if a primary key has a single attribute, yeah, that's the one case, single attribute, then the clause can follow the attribute directly. Yeah, that's the easy case. So we just append that primary key clause right after that attribute. Then we declare it as the primary key. Okay, but that's for the single attribute case. Yeah. Example here. Department D number. Yeah, department number in our department table. So we can write the D number column declaration in this way. Integer type, so D number, the field name, data type int, then primary key clause, we append this clause right after dnt, int, yeah. Then we make it a primary key. Okay, very simple. Yeah. But that's a single attribute primary key case. Later we will see multiple attribute primary key case. Another form of primary key clause, yeah. So another form, yeah, primary key. Yeah. So we do not append directly, okay? We do not append directly after that column or field line, yeah. We do it still in the same table, but at the end of the table, yeah. So we add that primary key clause in this way, okay? Yeah, we write one line at the end of table. So this primary key clause, this one line, yeah. Primary key parenthesis D number, yeah. D number, okay? Yeah. So the create table. Okay, yeah. So you define, row, field by field. Then, after all the fields, then here you write this primary key clause. Okay, yeah. So this is the second way. Yeah. Second way. All right. The third way. Composite primary key. Composite primary key for more than one attributes. Yeah. So you may ask, some of you may ask, why we use more than one attributes? Yeah. The reason is simple. Because if you use a single attribute, none of the single attribute have the unique values. There are situations, none of the single attribute or single field, their values have the uniqueness property. If that happens, then you cannot find a single attribute primary key. But it's possible you can use more than one attribute. You group them as tuples. Yeah, that's also tuple. You group them as tuples. Then you may define composite primary key. Yeah. So here we use example. Yeah. Still use this way, the primary key clause at the at the bottom of the table definition, but in the parentheses, you specify this example. You specify two field names. Yeah. ESSN. So this is in the dependent table. Okay, this is in the dependent table. Dependent table. Okay. Yeah. Dependent table because ESSN, this field does not have the unique values. Dependent name, this field does not have unique values. But if you combine them, okay, you combine these two fields, you use both of their values, then as a tuple, the tuple values are unique. So you can define a composite primary key in this way. Okay? Yeah. Yeah. So here you have this concept, composite primary key concept. Yeah. So some of our questions, we need to use this composite primary key concept. Yeah. Then the third way to declare primary, alter table. So you saw one example before. Yeah. So alter table, you add primary key. This is a single attribute case, but if you have the, more than one multiple attribute case, composite key, you can also do in this way. You can also do in this way. Okay? All right. So that's the primary key, the three ways to define primary keys, especially, yeah, the composite primary key. Yeah, sometimes you need to use the composite primary key. Okay, all right. For the key, it has the same structure with the primary key. Yeah, same structure. Yeah, but you know the difference between key and a primary key. Okay, primary key each table you can only have one primary key, right? But for the key fields, each table you can have multiple key fields. Yeah. All right. Use the unique clause three ways. Yeah, you can alternate secondary keys. Yeah, because the primary key, they are secondary keys. Not. Yeah. Unique clause can also be specified directly. Yeah, just similar to the way we specify the primary key. Single attribute key. Yeah, D name, department name. Okay, then append this unique keyword. Yeah, or add after. Yeah, you can add later. Later you include a line unique clause, parenthesis, dname. Yeah. The syntax similar to that we use for the primary key syntax. We just change primary key to unique. Yeah. All right. Then composite key. Yeah. You can also declare composite key. Use 2 fields. Yeah. 2, 3 more. Yeah. 2. Yeah. Most of the time people use 2. Yeah. Yeah. 3, 4. The more number of fields, then the probability will be smaller. Yeah. Then alter table statement. Yeah. Add a constraint name. Yeah. Unique. Yeah. Yeah. Here the constraint name. So this we will talk about later. When we give a name to the constraint, later we can use this name to modify this constraint. Yeah. Sometimes you want to change the constraint. If you have a name, you can make the change easily. If you don't have a name, if you want to change, you need to delete it first. You need to drop it. Then you add a new one. Yeah. Yeah. All right. Yeah. We run out of time. Yeah. But we finished 8 slides. There is total 9 slides. The last slide we will finish next time. Yeah. All right. So let's stop right here. Yeah.